Welcome to Nimu's World. It's me Nimesh Naik. Today I'm discussing CSIR net question June 2019. Topic real analysis. It's a part B question. Question: let Gn of x is equal to nx divided by 1 plus n square x square for all x belongs to 0 to infinity. Then which of the following is true as n tending to infinity? First option, Gn tending to 0 pointwise but not uniformly. Second option, Gn tending to 0 uniformly. And third option, Gn of x tending to x for all x belongs to 0 to infinity. And fourth option, Gn of x tending to x divided by 1 plus x square for all x belongs to 0 to infinity. Before entering the question, we want to know what is pointwise convergence and what is pointwise limit function and what is uniform convergence and how to check uniform convergence. So we go through some definitions. First, pointwise convergence. Let a D be a subset of R and let a sequence Fn be a sequence of functions defined on D. We say that convergence pointwise on D if limit n tending to infinity Fn of x exists for each point x in D. If sequence Fn is a pointwise convergent, then the function defined by limit n tending to infinity Fn of x is equal to f of x for every x in D is called the pointwise limit of the sequence Fn. And uniform convergence. Limit n tending to infinity Fn is equal to f uniformly convergent means limit n tending to infinity supremum of mod Fn of x minus f of x such that x belongs to D is equal to 0. We check the uniform convergence by using MN test. So MN test for uniform convergence. First we want to find limit n tending to infinity Fn of x is equal to f of x. And the second step, say mod Fn of x minus f of x is equal to g of x. Next we want to find the maximum of g of x. To find the maximum of g of x, just to find the extremum point. For that we want to solve g dash of x is equal to 0. Suppose x naught is a solution of g dash of x is equal to 0. That is x naught is a extremum point. Next we want to check whether g double dash of x naught less than 0 or not. If g double dash of x naught less than 0, then g of x has a maximum. Then the fourth step, if limit n tending to infinity supremum of mod Fn of x minus f of x such that x belongs to D, which is equal to limit n tending to infinity supremum of mod g of x such that x belongs to D, which is equal to 0, then the convergence is uniform. Otherwise, it is not uniformly convergent. Now we go to the question. We want to find the pointwise limit function. We have Gn of x is equal to nx divided by 1 plus n square x square. To find the pointwise limit function, limit n tending to infinity Gn of x, which is equal to limit n tending to infinity nx divided by 1 plus n square x square, which is equal to limit n tending to infinity x divided by n whole divided by 1 plus n square plus x square, which is equal to 0. So we get the pointwise limit function of the sequence Gn of x is 0. That is Gn of x converges to 0 pointwise on 0 to infinity. Our third option says that Gn of x tending to x for all x belongs to 0 to infinity. But it is also a wrong statement because we get Gn of x converges to 0 pointwisely. And also our fourth option is Gn of x tending to x divided by 1 plus x square for all x belongs to close to 0 to infinity, which is also a false statement. So we can conclude the third and fourth options are wrong. Now we want to check the uniform convergence. For that, mod Gn of x minus g of x, which is equal to modulus of nx divided by 1 plus n square x square minus 0, which is equal to modulus of nx divided by 1 plus n square x square, which is equal to nx divided by 1 plus n square x square, which is equal to h of x, say. Next we want to find the maximum of h of x. For that we want to solve the equation h dash of x is equal to 0. So first find h dash of x. So h dash of x is equal to 1 plus n square x square into n minus nx into 2n square x whole divided by 1 plus n square x square whole square, which is equal to n plus n cube x square minus 2n cube x square whole divided by 1 plus n square x square all square, which is equal to n minus n cube x square whole divided by 1 plus n square x square all square. Then h dash of x is equal to 0, which implies that n minus n cube x square whole divided by 1 plus n square x square all square is equal to 0, which implies that n minus n cube x square is equal to 0, which implies that n cube x square is equal to n, which implies that x square is equal to 1 by x square, which implies that x is equal to 1 by n. So we get x is equal to 1 by n is a point of extremum. Next we want to check whether that point is a maximum point or not. For that first we want to find h double dash of x. So h double dash of x is equal to 1 plus n square x square all square into minus 2n cube x minus n cube x square into 2 into 1 plus n square x square into 2n square x whole divided by 1 plus n square x square all power 4, which is equal to minus 6n cube x plus 2n cube x cube whole divided by 1 plus n square x square all cube. Next we want to find h double dash of 1 by n. So h double dash of 1 by n is equal to minus n square divided by 2, which is strictly less than 0. So we get x is equal to 1 by n is a point of extremum. We have h of x is equal to nx divided by 1 plus n square x square. Then find limit n tending to infinity h of 1 by n, which is equal to limit n tending to infinity n into 1 by n divided by 1 plus n square into 1 by n square, which is equal to 1 by 1 plus 1, which is equal to 1 by 2, which is not is equal to 0. Therefore, it is not uniformly convergent. That means the given series is point-wise convergent, but it is not converged uniformly. But our second option says that Gn of x tending to 0 is uniformly. So it is a wrong statement. And our first option says that Gn of x tending to 0 point-wise, but not uniformly. So our first option is correct one. If you like my video, please subscribe, share and like my channel.